हाय एवरीवन, आई एम देवाज्योति फ्रॉम IIT भिलाई, आपके मेंटर एडमिशन जंक्शन से। आज हम लोग देखने वाले हैं एक मोस्ट इम्पोर्टेंट टॉपिक जेई एक्सपीरियंस वालों के लिए है कोऑर्डिनेशन कंपाउंड। इनके इजी मेथड, कैसे कैलकुलेट करते IUPAC नेम्स एंड हाइब्रिडाइजेशन। ठीक है, तो लेट्स स्टार्ट। Firstly, let's see what is coordination compound. Coordination compound is basically a complex compound which is formed by some elements with one central metal. Okay, and in our daily life, why do we need coordination compound? Because these are very essential for catalysis, bioinorganic chemistry, एडवांस मटेरियल साइंस। हम लोग देखेंगे कैसे नोमेनक्लेचर किया जाता है, समझेंगे इनका इलेक्ट्रॉनिक स्ट्रक्चर और डीपली देखेंगे मोलिकुलर बिहेवियर और रिएक्टिविटी। नाउ लेट्स सी इजी स्टेप्स टू कैलकुलेट IUPAC नेम्स। ओके, so first one is identify the central metal. Okay, we should identify the central metal first, then apply numerical prefixes. We should apply the numerical prefixes. So firstly you will ask what is central metal. Okay, let's suppose this is one metal NiCO whole 4 Cl minus 2. So here what is central metal? Nickel, Ni. Okay, and these are what? Anionic ligands. Okay, so this is full coordination compound. So I have identified the central metal. Now there is 4, so I will use tetra for that. Okay, here another example you can see, which is CONH3 whole 4 Cl2Cl. Okay, use tetra pentahexa for multiple identical simple ligands. So where should I use here? At first, tetra. What is tetra? 4 NH3 is used. Okay, now after that, using numerical prefixes, we have to list them alphabetically. Okay, so in alphabetical order, which ligand will come, will place. And always remember, anionic ligands come before neutral ones. So NH3 is your neutral ligand and anionic ligand is Cl. Central metal is cobalt in CONH3 whole 4 Cl2Cl. Okay, now after all three steps, we should define the oxidation state and give the full IUPAC name. Okay, so the name is tetraamine dichlorodo cobalt. Oxidation state is given 3 chloride. Clear? Next, now always remember, anionic ligands start with O suffix, chloride to chlorodo, cyanide to cyano, like this. Neutral ligands with NH3, amine, H2O, aqua, CO, carbonyl, ano, nitrosyl. Okay, what is the pronaming strategy here? Use bis, tris, tetra keys when ligand names already contain numbers or are complex. Naming sequence are what? Anionic elements first, then neutral, and make sure alphabetical order. Next, hybridization. Let's go. First, what is S? So S orbital look like this. What is P? There are three. One is Px, one is Py, another is Pz. In three different axes: Px, Py, Pz. Okay. Now, if there are four ligands, then the hybridization will be sp3. This is very weak field ligands, high spin configuration, and the angle between them is like this. The angle between them is 109.5 degree. dsp2 is very within plane, you can draw. Okay, and that is very strong field. 1d, 1s, 2p. The ligands are under nickel, pd, pt, and low spin. Bond angle between them is 90 degree. In octahedral, the hybridization is d square sp3 sp3 d2. Okay, most common geometry, inner d2 sp3 or outer sp3 d2 orbital complex. Bond angle say 90 degree. What is tip? Strong field ligands Cn minus Co favor low spin configuration, and weak field ligands Cl minus F minus favor high spin configuration. So we have seen the IUPAC naming steps and hybridization steps. If there is four ligands attached, octahedral geometry expected. What is strength of that ligand? Cn minus is very strong field ligand, promotes electron pairing, low spin. Hybridization type क्या है? Strong field octahedral d2 sp3. For Fe 2 plus Ar 3d6, pairing occurs in 3d orbital, leaving 2 3d 1 4s 3 4p for bonding. Okay. In summary, what we have studied: IUPAC name must study, hybridization strategy, practice those things, name regularly, make hybridization using our pro tips. For such kind of easy and very important content, follow Admission Junction. See you on next video.